As we just saw, the diodes allow the positive half of the sine wave to pass, but this time the negative half is also allowed to pass, although this has now been inverted to turn it into a positive half also. This gives us a better DC supply because the pulsating has greatly reduced. But we can still improve this further. We simply add in some capacitors to smooth out the ripple and eventually get it to a smooth line closely mimicking a DC supply. We've covered how capacitors work in great detail in our previous video. Do check that out, links down below. So how do we test the diode? So we take our diode and our multimeter. We connect the black probe to the end of the diode with a stripe. We then connect the red probe to the opposite end. When we do this, we should get a reading on the screen. For example, this model 1N4001 diode gives us a reading of 0.516 volts. That is the minimum voltage it takes to open the diode to allow some current to flow. If we now reverse the leads connected to the diode, we should see OL on the screen, which means outside limits. That's telling us that it's not been able to make a measurement, and that's a good thing, because it means it can't complete the circuit, so the diode is doing its job. If we were to get a reading connecting on both configurations, then the component is faulty and shouldn't be used. To test the diode in a circuit for voltage drop, we simply move the multimeter into the DC voltage function, and then we place the black probe on the stripe end and the red probe on the black end. This will give us a reading, for example, of 0.71 volts, which is the voltage drop.